You're listening to Lead AI.dev, your daily updates on AI development. Today's topic is VAKRA benchmark reveals critical AI agent failure modes in 2024. Here's a quick overview. IBM's new VAKRA benchmark reveals systematic failure patterns in AI agents, providing developers with critical insights for building more reliable reasoning systems. Now, let's ask our analyst about these developments. What's new? VAKRA benchmark exposes AI agent reasoning failures.
IBM Research has released VAKRA, a comprehensive benchmark that systematically evaluates AI agent reasoning capabilities and tool use patterns. The benchmark reveals critical failure modes that occur when agents attempt complex multi-step reasoning tasks, particularly in scenarios requiring tool orchestration and sequential decision-making. VAKRA stands out by focusing not just on successful completions, but on understanding where and why AI agents break down during reasoning processes. The benchmark framework evaluates agents across three core dimensions: reasoning depth, tool selection accuracy, and failure recovery mechanisms. VAKRA tests agents on 500 plus carefully crafted scenarios that mirror real world complexity, including nested function calls, conditional logic chains, and error handling situations. Each test case includes detailed annotations about expected reasoning paths, allowing researchers to identify specific points where agent logic diverges from optimal solutions. Unlike existing benchmarks that primarily measure end to end performance, VAKRA provides granular analysis of intermediate reasoning steps. The framework captures decision trees, tool invocation patterns, and error propagation mechanisms that occur during agent execution. This approach has already revealed that current state of the art agents fail in predictable patterns, particularly when handling ambiguous instructions or recovering from partial failures in multi tool workflows. 500 plus test scenarios covering reasoning depth from 2 to 8 sequential steps, 3 evaluation dimensions: reasoning accuracy, tool selection, failure recovery, detailed annotations for expected VZ actual reasoning paths, support for both open source and proprietary agent frameworks, standardized metrics for comparing agent performance across different architectures.
Thank you for that analysis. Let's move on. Who benefits from VAKRA agent analysis?
AI researchers and agent developers working on production systems will find VAKRA's failure mode analysis particularly valuable. Teams building customer facing agents, automated workflow systems, or complex reasoning applications can use these insights to identify potential breaking points before deployment. The benchmark is especially relevant for developers working with LangChain, AutoGPT, or custom agent architectures where understanding failure patterns directly impacts system reliability. Enterprise teams implementing AI agents for business process automation will benefit from VAKRA's systematic approach to evaluating agent robustness. The benchmark helps identify which reasoning patterns are most likely to fail in production environments, enabling teams to build more defensive agent architectures. Organizations deploying agents for customer service, data analysis, or decision support can use these findings to set appropriate expectations and build fallback mechanisms. Individual developers and researchers exploring agent capabilities should approach VAKRA selectively. While the benchmark provides valuable insights, teams working on simple, single step agent tasks may find the complexity analysis less immediately applicable. The framework is most useful for projects requiring multi step reasoning or tool orchestration, rather than basic prompt response patterns. Production AI teams building multi step reasoning systems, enterprise developers implementing business process automation, researchers studying agent failure modes, and recovery mechanisms teams working with complex tool orchestration workflows.
Great insight. Really helpful context. How to get started. Step-by-step VAKRA implementation.
Begin VAKRA evaluation by installing the benchmark framework through the official Hugging Face repository. The setup requires Python 3.8 plus and includes dependencies for multiple agent frameworks, including LangChain, OpenAI's function calling, and Anthropic's tool use APIs. Configure your environment with API keys for the language models you plan to test, ensuring rate limiting is properly configured to avoid quota issues during extensive benchmark runs. Configure your agent architecture within VAKRA's evaluation framework by implementing the standardized agent interface. This involves wrapping your existing agent logic to conform to VAKRA's input/output specifications, which capture both final results and intermediate reasoning steps. The framework provides adapters for common agent libraries, but custom implementations require mapping your agent's decision-making process to VAKRA's logging format for proper analysis. Execute benchmark runs by selecting appropriate test suites based on your agent's complexity level. Start with the basic reasoning tasks, 2-3-step scenarios before progressing to complex multi-tool workflows. VAKRA generates detailed reports showing failure points, reasoning divergence patterns, and comparative performance against baseline agents. Use the visualization tools to identify systematic weaknesses in your agent's decision-making process. Install VAKRA framework from Hugging Face with Python 3.8 plus requirements, implement standardized agent interface or use provided adapters, configure API keys and rate limiting for target language models, start with basic test suites before advancing to complex scenarios, analyze generated reports using built-in visualization tools, compare results against baseline agents for performance context.
That's a very interesting point. Tell us about competitive context. How VAKRA changes agent evaluation.
VAKRA differentiates itself from existing benchmarks like Agent Bench and Tool Bench by focusing specifically on failure mode analysis rather than just success metrics. While Agent Bench measures task completion rates and Tool Bench evaluates tool selection accuracy, VAKRA provides detailed breakdowns of where and why agents fail during reasoning processes. This granular analysis approach gives developers actionable insights for improving agent robustness, rather than just comparative performance scores. The benchmark's emphasis on reasoning transparency addresses a critical gap in current evaluation methods. Unlike black box testing approaches, VAKRA requires agents to expose their decision-making process, enabling researchers to understand failure patterns at each reasoning step. This approach has already revealed that many high-performing agents on traditional benchmarks exhibit brittle reasoning that breaks down under specific conditions not captured by end-to-end metrics. VAKRA's limitations include its focus on structured reasoning tasks, which may not fully capture the complexity of open-ended agent interactions. The benchmark also requires agents to implement specific logging interfaces, potentially excluding some existing agent architectures from evaluation. Additionally, the current test suite primarily covers English language scenarios, limiting its applicability for multilingual agent development. Focuses on failure analysis via success-only metrics of existing benchmarks, requires reasoning transparency, unlike black box evaluation approaches limited to structured tasks. In this open-ended interaction complexity requires specific logging interfaces, potentially excluding some architectures.
Good analysis. Let's continue. What's next? Future implications for AI agent development?
IBM Research plans to expand VAKRA with additional test scenarios covering multimodal reasoning, long-term planning, and collaborative agent interactions. The roadmap includes integration with popular agent development frameworks, making failure mode analysis a standard part of the development workflow. Future versions will incorporate dynamic test generation, allowing the benchmark to adapt to emerging agent architectures and identify novel failure patterns as they develop. The benchmark's influence on agent development practices is already visible in how teams approach robustness testing. Major agent framework developers are beginning to incorporate VAKRA-style failure analysis into their testing suites, suggesting a shift toward more rigorous evaluation standards. This trend indicates that future agent development will prioritize reliability and failure recovery alongside pure performance metrics. VAKRA's systematic approach to failure analysis represents a maturation of the AI agent field, moving beyond proof of concept demonstrations toward production-ready systems. The benchmark's insights will likely influence the development of more defensive agent architectures, better error handling mechanisms, and more transparent reasoning processes. This evolution positions agent technology for broader enterprise adoption by addressing reliability concerns that have limited deployment in critical applications. Planned expansion to multimodal and collaborative agent scenarios, integration roadmap with major agent development frameworks, dynamic test generation for emerging agent architectures, industry adoption of failure-focused evaluation standards.
Great analysis. So what are the key takeaways from all of this?
VAKRA benchmark reveals systematic failure patterns in AI agents during multi-step reasoning tasks, providing actionable insights for building more robust systems. Current state-of-the-art agents fail predictably when handling ambiguous instructions or recovering from partial failures in tool orchestration workflows. The benchmark's granular failure analysis approach enables developers to identify specific breaking points before production deployment. VAKRA's emphasis on reasoning transparency is driving industry adoption of more rigorous evaluation standards beyond simple success metrics.
And what market signals should our listeners watch for?
Enterprise AI agent reliability standards. VAKRA's systematic failure analysis approach indicates growing enterprise demand for reliable AI agents in production environments. The benchmark's focus on robustness over pure performance metrics reflects market maturation, where businesses require predictable agent behavior for critical workflows. This shift toward reliability first evaluation suggests that future agent development will prioritize defensive architectures and comprehensive error handling, potentially creating competitive advantages for vendors who demonstrate superior failure recovery mechanisms. Agent framework consolidation pressure. The benchmarks requirement for standardized logging interfaces and reasoning transparency creates pressure for agent framework consolidation around common evaluation standards. Frameworks that cannot easily integrate with VAKRA style analysis may face adoption challenges as teams increasingly prioritize systematic evaluation capabilities. This dynamic could accelerate the dominance of major frameworks like LangChain while pushing smaller or proprietary solutions to adopt compatible interfaces or risk market marginalization. Research investment in agent robustness. VAKRA's revelation of systematic failure patterns in current agents signals significant research investment opportunities in agent robustness and failure recovery mechanisms. The benchmark's findings suggest that current approaches to agent reasoning are fundamentally brittle, creating demand for new architectural approaches that can handle uncertainty and partial failures more gracefully. This research direction could spawn new categories of agent development tools focused specifically on reliability and defensive programming patterns.
What should developers and operators do with this information?
Implement VAKRA evaluation for any production agent system handling multi-step reasoning tasks within the next 30 days to identify potential failure modes. Integrate VAKRA-style failure analysis into agent development workflows when building systems requiring tool orchestration or complex decision-making. Benchmark existing agent architectures against VAKRA standards before enterprise deployment to establish reliability baselines and identify improvement areas. Adopt VAKRA's reasoning transparency requirements for agent systems where failure analysis and debugging capabilities are critical for maintenance and improvement.
Thank you for listening to LeadAI.dev. Stay tuned for our next daily updates in this rapidly emerging market.